Going to redo assignment, I believe it was 7 with the solid. So file, and then to merge. When we go to merge, we've given a pair of solids. So when you do the pull down list, you'll see the Mastercam files. I just the interchange graphic standard AutoCAD DWGs. Pair of solids are what we're going to end up with, but Pro-E step files. Occasionally you'll see SAT files. Not so often Rhino. SolidWorks files will come in directly. Solid Edge, Inventor, Key Creator, which used to be CAD Key, I believe, and then ASCII, STL are the triangulated. Space claim documents, a Libre, and then pretty much can go to all files. So if I select those, I grab the X_T, select a new location. Well, should be okay on scale, coming in 1:1. Rotation, not so much. Let's see if we reset, reselect. Now it's pretty much on the corner, so that was the origin of the part, or the origin of the stock. So out of SolidWorks, I generated a stock body, and that will show up under solids as stock, and under the levels will show up as visible stock A4. Alright, so that being the case, let's go ahead with our geometry and we will transform. Move to origin will work for both. And so my stock size, pick up the geometry, we'll right click and go back to fit. And that puts the stock at 0, 0. Okay, so we're pretty much ready to set the machine. So mill, and we'll go with the default. Set our properties. So again, nothing really under files, just kind of double checking the toolpath, the machine, the control. Tool settings, 1, assign, warn. Start with 1. We'll go with the mill library, set it to 6061. And then doing the stock setup, I can go to all solids, and that'll find the size of my geometry. And we'll go ahead and accept. Alright, so at this point, I can go back over the levels and say, make the stock not visible, and then jump back to the toolpaths. Alright, with the solid geometry, we can use feature-based machining. So mill toolpaths, and we'll go ahead and start with the FBM drill. And I have mixed feelings about FBM because it generates a lot of operations that maybe we wouldn't normally have to go through. So there's a trade-off of every size hole, if we spot every size hole, will get a different spot. And then the whole machining, how we're going to access those geometries. Alright, so initial hole detection. Let's go ahead and create the points at the top of the hole. And those more for reference. Hole detection include blind holes, chamfers, split. Split would be going through like a tube or a pocket and showing up on both sides, so where there's a gap. Limit search plane to the top. We're not going to look for side geometry. Set normals towards tool plane on detect. And delete existing features on detect. Minimum diameter of 32nd, maximum 1 inch. That's pretty much between our range. Hole mapping, if there is a list. I have to look more into that one. I'm not familiar with it. Deep drilling. Use deep drilling when the hole depth to diameter ratio is greater than 1. And spot drilling, want to go to edge break 100% or 375 deep. And then pre-drilling, drill pilot holes. So step drilling is what I take that to be, so no pre-drilling. And then hole milling, we don't have any counterbores in our geometry. We do have the countersink, but basically the pockets and the other geometry show up. So let's just go with the through holes. And maximum tool diameter, probably go up to 75%, and minimum 25%. And do we want to do the circle mill or the helical bore? Alright, so whichever one's selected, we'll get that geometry. Single pass circle mill, basically going in. Finish, circle mill defaults, and circle mill defaults, no stock to leave. Entry, helix, maximum minimum radiuses, overlaps, and 45 degrees. So if we went back to the helical bore, then rough pitch 3 inches, number of rough passes 1, rough pass step over 40%, long tool feed rate at final depth 20%. Now rough pitch is gonna, I'm not sure if that's an angle or a measurement. Okay, so we'll have to see what it generates. Stock leave on walls, none. Entry exit 45 degrees starting at the center, overlap 10%. Let's stay with the inch tools on our tool selection, so it's going to do some calculation. Use the tool library and create as needed. Standard sizes, consider flute length. Linking parameters, tip compensation for through bores, additional breakthrough. Let's just give it another 10 thousandths. Clearance and retract. Tap and ream, pull up the tap so it doesn't bottom. And then additional, don't really need, and then the features. Alright, so I'm going to accept. It goes through and does the calculation. Peck drills, drill counterbore. Alright, so everything's kind of bunched up by order. And so what we would need to do then is find our sort. And let's sort by tool. And go ahead and let it pull all of the spot drills to the top. Alright, so 210, or 201 tap drill did not pick up the tapping operation. The peck drill 290, 316, 332. Letter X, alright, and drill counterbore went to 421. Well, and except for the countersink, don't think I changed anything there. So really it went right to the drill operation, and so we'll need to make sure that that is my tap drill is selected. We're going to copy it, paste it at the end of the group, and then for its parameters we'll pick up the tool. Not sure what it picked for 8 and 9 there. Alright, so we're going to select library tool like we normally would, filter to none, pick up our tapping right hand, and we'll go to 1/4 20. and select. Alright, so quarter 20 tap. Not going to run at 7600, so I'm not going to go through each of these on the video and change all the feeds and speeds or put in the notes, but this gives us a good start to start going through the geometry. Cut parameters goes to tap. Linking parameters, now we're telling it minus 0.5 in incremental, so let's change that to 0.4 to leave room for backup. Again, if we're on the on a tooling plate, clamping fixture, then depends on if there's relief whether we run the tap through the part. No tip comp with the tap, and we'll go ahead and accept. Alright, so with 17, then we'll go back and regenerate the toolpath. Alright, so the work strategy here then would be to go through each of the parameters, go back to the toolpath type in the tool, double check that our surface feet per minute and spots are noted, and then going to the next operations, basically go through all of those geometries. Alright, so the next would be to mill toolpath, and we're going to have it look for mill and automatically initial feature detection. Use tools from the part file, the tool library, create if needed. Search plane is still the top, and then we can group by feature and zone. So it will break out to subfolder locations. We want to find through features, stock to leave, none. Holes greater than this diameter, mill around features with this cycle, pocket. Slug cutting, leaving the centers of the pockets, or as opposed to turning them to dust, to chips. Rough tooling. We're not doing facing, so on rough tooling, let's go ahead and select a tool from the library, and we'll filter back to none. Go for the end mill, and we'll pick up a 1/2 inch flat. Alright, so we're not doing any rest milling that I can think of, but we'll go with finish tools. If we do need a rest mill, then it can select it. And we already picked select tool from the part file, since we already picked the 1/2 inch tool. We'll go ahead with the same tool. Internal fillets, let's see, what else do we have? Always use flat mills. Alright, so that's giving it some direction on making the tool selection. No facing. Yes, we want roughing, climb, using the defaults and the depth cuts. Stock to leave on walls, we'll go with 5/1000. None to leave on floor. And long tool values when the length to diameter is greater than 10. So rest milling, let's go ahead and apply these. We'll let it pick any of the rest mill. Don't really need to go back and do floor finish. Wall finishes, let's see, entry, exits, no stock to leave. And hole milling is turned off. We did all that with the drill. And then linking parameters, clearance planes, feed plane, and whatnot. Any additional settings, flood coolant is on. And features is finding our 2 pockets in their respective zones. Okay, so we go ahead and hit OK. It drops below the feature-based machining drill to the top. And we're did my parameters go? Ah. Okay, so it added the list. I would like to have that with my geometry, and alright, so we need to generate those toolpaths. Alright, so it flashed an operation 13 error. Alright, so I'm not sure why it didn't go identify all of that on the first go around, but it did then break these into two separate groups for the machining zones. Alright, so the 2D high-speed 2D area mill, and then the standard pocket, and then the second high-speed into the corners. So the advantage here is that we're going to be able to turn the displays off at those group levels and see what is actually being generated. Okay, so again, quite a few operations, maybe more than what I would have put in the process, but since I get them automatically, it'd be worth the time to go through and decide which ones are going to be useful, which ones to keep, and which ones to kick out. All right, so let's go with the beginning tool group. Since I didn't add anything to it, I'm just going to move it after. And then that way we can put the insertion arrow a little bit lower. Alright, and then do the toolpath group, mill toolpaths. I'm going to put in a contour. And so it pretty much recognized our features up to this point. Normally you would be in the wireframe chaining at the construction plane. And with the solids, none of this is going to be able to select anything. We don't have any usable geometry. So when I go over to solids, it's going to pick for 3D. And I want to go with linked edges. I'm going to turn the edges off. And we'll rotate around. And I want to knock this corner off. Now what I didn't do in between those groups was put in that manual entry to do the clamp change. We've done all the interior geometry. We're going to have clamping locations, and then clear of all the clamps. Then on the outside we'll run around the perimeter. Alright, so going to that linked edge, I picked the first piece of geometry, and we're doing the chain, except now we're chaining. And there is a small flat there. Okay, so it wants the small flat in the mix, and so that'll knock off that corner. And I'm going to go back into the chain, and about the same number of paths will clear out the sides. So right click, add chain. And just need to find that last little fillet there. Okay. And let's go Alt-1 and we will fit. Alright, so arrows and directions look good. Notice that within the solid chain then is the linked edges and then all of the edges that we selected. Alright, so that's how it gathers up that chain information on the solid geometry. Alright, so going back into the tool, 1/2 inch flat end mill. The 1/4 inch flat was added for the rest machining in the pocket. And again, I'm not going to go through on the video and update all of my spindle speeds and feed rates, so we'll catch that on the next pass. Cut parameters. stock to leave on walls, we'll leave 5 thousandths. No depth cuts. Lead in, lead out. So I'm going to shrink this up a little bit. 100 thousandths on the lead in, 100 thousandths on the arc. 45 degrees should get us engaged in the material. Copy everything over. It's not a closed contour, but I'm going to still turn off the entry exit. Not concerned with breakthrough. Yeah, let's go ahead and give it 5 thousandths of breakthrough amount, because we're going to depth. And then our multi-passes will take, I don't know, 4 at 200 and see what that looks like. Alright, so I left 5 thousandths on the wall. If I go to the finish pass, then that would take me to the wall. I'm going to add a separate contour that runs around the entire geometry, so we will bypass the finish. No tabs. Linking parameters. Alright, we still have to be concerned with the clamps, but since this is, well, we're going to move from this side to this side. As long as we're in a linear distance, we should be able to navigate around the clamps. So we have absolute, incremental, and associative. If I go with associative, then it's going to ask me to pick. And the pick will be the endpoint. And shows as 0, but if we switch over to absolute or incremental, absolute will get the minus 0.5. Alright, so we'll see what that looks like. Go back to the front view. Let's see. Okay, so that picks my geometry. And then the last contour will be, instead of picking linked edges, we're going to go for a loop. And when we grab the loop, it's going to ask us to pick a reference face. Other would be for it to go, well, vertical. And right now it's finding the correct geometry around, so we go ahead and hit OK. And OK. And it pretty much kept all of our settings from the previous contour. We'll go into where. No stock to leave on the walls. Lead in, lead out should be okay. Inner exit still turned off. Breakthrough will be alright. No multi-passes this time. And linking parameters, if we jump back, absolute. Looks pretty good. So I'm going to the top view. Okay, I thought I was going to the top view. Alright, so that gives me my toolpath, and let's see. Cannot see my toolpath around the outside. So since I picked the geometry, let's go ahead and change the side. That's going to put me into conventional. So let's go ahead and reverse the chain. That'll put me in climb. Make sure that that's selected and go ahead with the toolpath. And then yes, it can regenerate. So let it run through. Okay, so number 13. Is a pec drill. No. Alright, let's see if we can find out where that error was at. No operations. Okay. I don't need to see the error to make the correction, so interesting. Alright, so I know I saw that error. Maybe it no? Okay, we'll make sure that those are. Redetection. Okay. I don't think the geometry changed that much, but what that redetection would be is going back into the to the FBM level and having it generate the toolpath from there. But it's selected, so it should have updated. All right. Well, it gives me quite a few more operations than what I would have put in manually by myself. But the let's go ahead and verify. Oh, and again, helps to have everything selected. So spot drill. Alright, so the rest machining. Alright, so there's some cleanup that we could do in that rest machining. Alright, so that gives us the basic toolpath information. Going over into the to the solid verify. Okay. Operation number 13 has an invalid shoulder diameter, cannot be 0. Okay, unknown error. That was the hang up. Failure in tool definition. So interesting that that one comes up. Alright, so under the tool, we'll look down through here, shoulder length. Tip angle, diameter. Well, we'll see if it updates. Make sure that that one's selected. That is operation 13. Alright, so we'll see if we still get it. Okay, one of those strange, but can't really tell what it generated. Alright, so except for our extra little tab over here, knocks the corner out, so that maybe on my toolpath needs to be a separate, and this is still going to be a pretty heavy cut going in and out of the notch, but that gives me a good start for my geometry.